X and point Y, right? So this corresponds to your XY plane. Okay. So now over here, this is known as your stress A. Okay. And over here, this is your stress B. So if we were to calculate the principal plane, okay, so this will rotate by 2 theta p. Okay. So now we are going to calculate our tangent to theta p. Which is equal to 75. And then 75. Oh, no, not 75. I beg your pardon. Which is equal to 70. And we're going to divide by 75 minus by 30, which is 45. So 2 theta p, so 75 divided by 45 inverse tangent is equal to 59 degrees. Okay, go in the clockwise direction. And then theta p is equal to 29.5 degrees. Okay. So if we take this element and we rotate by, I'm going to rotate this. Oh, I can't rotate this image. Can I rotate this image? Weird. It's so weird. I can stretch. Okay, I'm going to rotate it by an arbitrary angle. Okay, I'm going to rotate by, I can only rotate by, hold on, bear with me. I'm going to copy. I'm going to go into a different software. And hopefully this software could rotate. So if we were to rotate by, hold on. Yeah, another software can rotate. So if I were to rotate by a certain angle, got it. Okay. So for this case, we rotate by, okay, we rotate. So this is the theta p, which is equal to 29.5. And we rotate in the clockwise direction. So that's where the original is here. Z, we rotate clockwise. Okay. So when that's the case, so let's say we wipe this out. Okay, there's no more shear, right? There's no more this, there's no. So we know that one of the values, right, correspond to what? Correspond to 158.216 psi. And the other one will go in by 8.26 psi. Okay, because it's at its principal plane, there is no shear now. Okay, there is zero shear now. Okay, so the next thing that we want to draw now, okay, we are going to draw the XY plane. Okay, so XY plane. So now I want you, so this is X, okay, and Y plane. So if I'm going to now draw the circle, I'm going to draw the element. Okay. So this is X, this is Y, and this is how the element look like in the XY plane, right? And then we have a compression of 8.26, 8.216, 8.216 psi. Okay, 8.216. So on the XY plane, right? So we know, let me zoom in and write this. Come on, Eugene. Where are we now? Okay. So I'm going to delete. Okay. So we know that this is our point X. Okay. So this circle draw. So this is point Y. Okay. So point Y, so stress B, right, is equal to what? Is equal to minus 8.216. So this circle that I'm going to draw, right, it belongs to the XY plane, right? Because I've just shown you that, right? I've just shown you this diagram over here. This corresponds to the XY plane. So you have compression 8.216, which is over here, right? And then stress X is equal to 0. So this is stress X. Okay, so for this case, stress X is equal to 0. So this corresponds to the XY plane. So therefore, this circle that we have drawn belongs to the XY plane. Can you all see that? Okay. So for the next circle that we're going to draw, right? The next circle we're going to draw, we are going to focus on YZ plane. Okay. No, not YZ. YZ we have drawn. Hold on. Did I write the right plane? No, this is not. The first one was not XY plane. This is in fact belongs to YZ plane. Okay. Then we have XY. So the next circle that we're going to draw, right? We're going to focus on the plane that we want to draw first. So it's going to be 0, right? And it's going to be tensile 1,5. So we are going to look at the, I'm going to draw the X. Okay, now this is my X, or this is my Z. And now this is my X. Okay, right? So when I draw the element now, when we're in the X, Z plane, over here, you have 158.216. Okay, so this is your point Z, or not your point Z, that is your principal stress. Okay, and then X is equal to 0. So X is equal to 0 over here. And then over here, this will be your what? This will be your 158.216, right? So now we can draw, I'll try to draw another smaller circle, okay, which I'm going to use red. Okay, close it now. Okay, so now this circle over here, I'm going to move it slightly. This circle over here, as you can see, now this, right? So one point is at 158.216. The other point is where it is at 0. So 158.216, and over here is equal to 0. So this is your XZ plane. Okay, over here, this circle belongs to your XZ plane. Okay, So what we have learned from here, right, is this is our first time sketching 3D Mohr circle. And now you know how to label the planes, like what plane does this circle belongs to. Unfortunately for this question, okay, the element is has equal surface area. There's no way to identify whether it is in plane or out of plane, unfortunately. Okay, so as I said, 3D Mohr circle is not that more difficult than 2D. Okay, we only have to draw 2 extra circle and how to identify which circle belongs to which plane. Okay, so now we are going to look at one question, and this question, okay, which you have on Avenue to Learn. Okay, this question has a lot of layers. Okay, and I'll explain to you what I mean by layers. Okay, so this is the question that we're going to look at. Right? And I have also posted the solution. Okay, so this is the solution, and the solution is very complicated. Yeah, I'll put the solution here. Okay, and this is the solution. Okay, going from left to right. Okay, you look at the solution. They are forming so many equation. Okay, so when I post the solution, don't try to figure out what's going on from the solution. But more important, okay, you have to look at the final value. So you have one value over here that's 60, one over here which is 122. Okay, and then you have how come you have like 160? This is reject. Okay, and what is going on down here? Okay, so look at the final value, which is more important than anything else, rather than trying to figure out the solution menu. Okay, use how I teach you, right, and solve the problem. Don't try to analyze the solution. Does not work. Okay, no, it does not work. These sets of equations are formed by understanding Mohr circle. So the way I teach all of you is I want all of you to construct Mohr circle. It's easier that way than trying to figure out what is going on down here. Okay, right. Okay, so let's look at this question. So you can see from this question, for the state of stress shown, determine the value of stress Y, for which that the maximum shearing stress is equal to 73 megapascal. So based on this diagram, okay, on the element, we have to figure out what is stress Y. And given to us, the maximum shear is 73. Okay, so like whatever we do before, this corresponds to a point X. This corresponds to a point Y, and this corresponds to a point Z. Okay, so what are the values that we are very sure? Okay, so we are very sure that stress X is equal to minus 50 megapascal. Okay, and we have shear XY is equal to shear YX, and this is equal to positive 48 megapascal. And what we are very sure is stress Z is equal to 0 megapascal. And what we are also very sure is shear XZ is equal to shear ZX is also equal to 0. Shear YZ is equal to shear ZY, and this is also equal to 0. So these are the facts that we're very sure. We only don't know what is our stress Y. So we are also given that we have to given that stress max, okay, is equal to 73 megapascal. Okay, so this is the condition that